As we start Chapter 3, we're going on to look at graphs and the rectangular coordinate system. The first type of graph that we look at is a bar graph, where they're asking us to determine the results of these two teams by looking at the scores of the various quarters. So, as a class exercise, as we look at it up here on the screen, we'll pause, and we could put the Celtics in this column and the Lakers in this column and see what you get for the first, second, third, and fourth quarters from reading the graph. And we'll start you off on this one here. The Celtics, first quarter is right about there. And I'm going to go for 16 on that. And now take a moment to fill this in. Now I found when I did this the first time, like this 17 here, looks more like an 18, but the totals they get is 88 to 82, so Celtics won. Now the point is figuring out a strategy, looking at the bar and then going over to this side to get a number. Okay. Now another type of graph that we'll see from time to time would be a line graph, where time is usually on the bottom here, and then amount is on the side. So these were years, and we're wondering from 1980 to the year 2000. So there's 1980 and the year 2000. What was the increase? Well, we started off with 4,000 and it went to 14,000. So the increase is 1,000. And again, the trend that they're showing is that it keeps increasing, and in organizing a graph. Now in this next part, we're going to do a little background work in which this will be a horizontal number line, where over on this side we have positive numbers, and over on this side we have negative numbers. And another line, number line, that's vertical to it, and again above it we'll have positive numbers, and below it we will have negative numbers. Now we see this is the typical rectangular coordinate plane, where the horizontal number line is the x-axis and the vertical number line is the y-axis. Now on this, we're able to plot what are called ordered pairs, in which there's an x value and a y value. And the pattern for that is if they were to give you, let's say, a 2, 3, we would start with the x value, start here at 0, go over 2, and then up 3 and put a dot here. And that's where this point would be plotted on the rectangular coordinate plane. Now notice the plane divides, or the graph divides the plane into 4 regions, which are called quadrants. This is the first quadrant, the second, the third, and the 4th, and we use Roman numerals to designate the quadrant. Now, as you can see, with 2 pluses for x and y values, this is in the first quadrant. This point in the second quadrant would be a -2 and a 3. That would be a second quadrant where the x term is negative. If they were both negative, that would be the third quadrant. And here, if the x were positive, while the y value is negative, we keep getting these phone calls from time to time, why this would be the fourth quadrant. So there is a little pattern, and we study that a little bit. So this is the background. We're ready for our next exercise. One thing we should mention, though, is this point right there in the center, where both values are 0, this is referred to as the origin of the rectangular coordinate plane. Now, somewhere in your booklet, we'd like you to make a little graph just by putting the 2 lines, the 2 axes, and then sketching where these would be. And we'll get back. So it should look something like that. And then point A is in the third quadrant. Now, point B, interestingly, is not in a quadrant, but we say it's on the y-axis. And these are both positive, so that's in the first quadrant. And D, since the x is negative, is in the second quadrant. Now, you'll be doing practice on this, and of course your quiz me's, as you develop your mastery skills. Now here they'd like us to produce what is called a scatter diagram, in which we are going to pair this data. Remember, time is on the x-axis, where amount would be on the y-axis, and these are in thousands. So we're looking at the first quadrant and how to put this data into it. Well, this is 0, 1, 2, 3. So this one's pretty straightforward. We can say that right here, this is 0, and go 1, 2, 3, 4, 5, and just have these for the years. So this would be 1, 2, 3, 4, 5. I could have spread them out a little bit more. Now, as we look at this data for the y-axis, it starts at 19 and goes to 26. So a technique that we could use is put like a little wiggly line there to indicate we're going to start here at 19, 20, 21, 22, 23, 24, 25, 26. So again, 19, 20, 21, so we set up our parameters on the side here, and now we're going to plot our data. So at the year 2000 it was 19, so I guess I could change colors and put a dot right there. The next year went up to 22, put a dot right there, and let's do all of these, as you will do them on your paper as well. So generally, instead of this little dip here, the trend was upward, increasing. We sometimes can run a line through our data and say this is the trend and sort of the average of what we have. In later courses, you'll be doing things like this. But once again, this is called a scatter diagram, where you are asked to make a graph. Now, in MATLAB, they'll ask you to pick out one. They'll have multiple choice, and my advice is put the data in a form like this so that you can accurately pick out what the answer is. For number 4, they're asking us to determine if these ordered pairs make the equation true or not. So for this, I've tried to sketch in some little charts. What I'd like you to do is just make what is called a T-chart, where we put the X value there and the Y value there, and write these in. 1, 4, 2, 5, 0, 15. And if we substitute these values into this equation, 5x plus y equals 15, does it make this equation true? So we'll give you some time, and we'll set this one up too over here. This is xy, and this is 1, 4, 8, 2, 0, 0, and the equation is x equals 1/4 y. And as a help, if we solve this equation for y, we would get y, just multiply both sides by 4, y equals 4x. So you can put these values in either of these equations to see if it's a true statement. And let's give you time for that. Now, in the first example, we get 5 plus 4 is 9, so this would be a no. This is 5 times 2 is 10 plus 5, 15. This is a yes. 5 times 0 is 0. 15 equals 15. This is a yes. And let's do these. And here, if we substitute, our y is 4, x is 1, 4 equals 4, yep. Here we're going to substitute 2 for the y, is 32, that one's no. And then if x is a 0 and y is a 0, 0 equals 0 is a yes. So again, you're going to be doing these for your practice and your quiz-mes, and then later, maybe on your test, you want to have a strategy to be able to do these correctly. Now, a variation of what we had above is this, in which we have the equation, put it over here, x plus 2y equals 6, and we're going to make a T-chart, x there and y there, and we have two values, so we have a 2 there, and we don't know what the y would be, but now we have a -3 here. We don't know what the x will be. So we substitute the 2 where the x is, and we get 2 plus 2y equals 6. Now solve for the y. Transpose that, we get 2y equals 4, y equals 2. So our answer here is a 2. And we can check it. If x is 2, y is 2, 2 plus 2 times 2 is 4. Yeah, this works. So this is correct. And then now we're going to put a -3 where the y is. So we have x plus 2 times -3 equals 6. So this is going to be x minus 6 equals 6. Transpose the 6. On this side it becomes a positive 6. So this would be a 12. And if we put a 12 there and a -3 in there, it's going to be 12 minus 6 is 6. And this one checks too. So the same technique here, where we're going to put a little t-chart and our values in there. And we have here a 6 first, and here a -1/3. So if x is a 6, we just put the little equation here, y equals 1/3 times 6 minus 2. So we're just substituting the 6 where the x is. So 1/3 of 6 is 2. 2 minus 2 is 0. So when x is 6, y is 0. Now this one's a little more tricky because we have a -1/3 equals 1/3 x minus 2. So we're putting our value of 1/3 where the x is. And here we can use that technique of getting rid of fractions by multiplying everything by 3. So here this is a -1 equals 1x, and then this is going to be a -6. We bring the -6 over as a +6, and this then becomes 5 equals x. And looking down at the answers, I see this checks, so we put a 5 there, and we're in good shape. All right, we'll continue on to our next lesson shortly.